I threw a document in the chat window. If it does not come through on Zoom, I also posted it in Blackboard in course content.
What did you say?
I said I put a document in the chat window, but if you can't pull it off of the Zoom chat, I also posted it in Blackboard under course content.
What is it for?
It's just all the notes I put up today for the final review.
Oh, okay.
Topics for the final. Chat window. All right, so here we go. So final on Tuesday. Like I said, I'll put it up around noon. I'll take it down around 9. You'll have 2 hours once you start the exam to take it. And it's about 43 questions, 42 multiple choice and 1 short essay. About a little over half of it is old content, and about half of it is questions about database and system design. So the old questions. Define what a computer is, dumb box of switches, only can turn on and off, that it has an operating system that is software. What's the difference between hardware and software? That the only language that it speaks is binary, which is a numbering system of 1s and 0s that represents the ons and offs of the hardware. That hardware and software in computer science is broken up into input devices, output, memory, and storage, and that we kind of use those words to define the computer system. It inputs information, it stores it, it processes it, and it outputs it. Stick in here. The information systems turn data into information. So that was that definition that says we use computer systems in business to turn raw, unorganized facts, which is data, into organized information that allows us to make business decisions, which is information. Besides hardware and software, one of the major components is the internet. So an internet is a network of networks sharing information using a common protocol, specifically TCP/IP. You should be able to define what the internet is. You should also be able to define what it's not. It's not a piece of hardware. It's not a piece of software. It is an idea. You should know the difference between peer-to-peer networks and client-server networks. That peer-based networks are small networks and everyone's equal and they have limited security. that client server networks are for larger networks, that they are secure, and that you have clients that get resources and servers that give resources. That software can either be local or cloud-based. If it's cloud-based, it lives on the internet, on the servers that are out there. And that if cloud-based storage, cloud-based software, cloud-based applications, all basically saying the same thing. Where is that information? Where is that data? It's on the internet. It's on the network of servers that make up the internet. Everybody with me so far?
Yeah.
Yep. Cool. All right. That one of the big things that IT people do is to make sure that your network is secure and that it stays able to provide information services. It can do that in a number of ways. The three main ways are to provide integrity, confidentiality, and accessibility. So you should know what those three words mean. That we want to make sure that the data is what we said it was, that it's fault tolerant. So if something goes wrong, our data stays the same as if something didn't go wrong. And that includes backup and redundancy. That it's confidential, that the only people that can see our data are the people that are supposed to see our data, and that it's accessible. That, okay, my data is over there and it's good data, I need to be able to access it. So I need to be able to get past denial of service. You should understand what the web is and how that differs from the internet. That the web is a network of documents written in the hypertext markup language, HTML. And you should be able to recognize HTML when you see it. That's the old stuff. Let me just I'm going to bring up the test. Did the share change? Are you looking at the test?
No.
No? Good. All right. CPU, RAM, internet, operating system, binary, integrity, security, confidentiality, hypertext transfer protocol, HTTP, and HTML, hypertext markup language, and www, World Wide Web. All right, good deal. All right, new stuff. Database. You should be able to define what a relational database is. And we gave examples of some big databases. We said that databases that run your entire enterprise are called ERPs, Enterprise Resource Planning. That there are lots of different relational databases. We gave examples of Oracle, SQL or SQL, Microsoft SQL, and Access, that they have tables. You should be able to define that a database is organized information and data about your entire company, that it is broken into tables, which is, there are multiple tables that make up a database. Tables are broken up into fields. There are multiple fields that make a table. That those fields have multiple records, and that records can contain a single point of data. So from smallest to largest, data, then records, then fields, then tables, then databases. That's a guaranteed question on the internet. Organize these words from largest to smallest. Databases are bigger than tables. Tables are bigger than fields. Fields are bigger than records. Records are bigger than a single point of data. That when I have a database, the language I use to pull data out of that database is called the structured query language, or SQL. And you should be able to recognize SQL when you see it. So when you see words, let's say, select from my database table, I don't know, employees, where department equals sales, select from table, that's SQL, that's SQL, that's the structured query language, the language that is used to pull data out of databases. That you use queries to pull data out of tables, and you use forms to put data in tables. Let's see, what else did I ask about database? That's about it. Questions about database stuff? I'd say that's like 8 or 10 questions, 5 of which are database table field record data. And last but not least, the system development life cycle. You should be able to define the system development life cycle and know the steps of the system development life cycle, those 7 steps that are the planning phase that defines the problem and sets the system requirements, the design phase that includes make versus buy decisions, doing RFIs for request for information, RFPs for request for proposal. You analyze TCO, which is total cost of ownership, all while doing the software development or system development life cycle, which is the SDLC. So kind of know what those acronyms are, know the steps. Once you have designed your solution, then you're going to implement your solution. So know that you can do a parallel implementation, a phased implementation, or a direct implementation, what the difference between those 3 are. And that finally you're going to have some type of, in a closed loop system, you're going to have a 7th step, which includes the feedback, so that you can redesign and start over. In an open loop system, it's a single solution to a single problem. It's not going to include feedback. Questions on that stuff? Okay. One open-ended question. 5 to 6 sentences. You're hired by blah, blah, blah. They want you to fix a problem called blah, blah, blah. Go through the system development life cycle to tell me how you would solve that problem. So your answer back to me is going to be 5 or 6 sentences that you're going to say, first I would analyze whatever problem I told you they have. I would define that problem exactly so I knew what caused the problem and why the problem exists and what a good solution would look like. Then I would do a request for information to get hardware and software solutions that would solve that particular problem, whatever I said in the question. Once I had that, I would do a request for proposal that looks at the total cost of ownership, that analyzes how we would implement it, and gives us a complete plan for solving the problem. Finally, I would implement the solution, probably using a direct implementation so that we could rip the Band-Aid off and immediately get the results that we wanted. Finally, we would do feedback to determine if we had actually solved our problem, and if we haven't, we would start the process over again. That is a 15-point out of 15-point answer I just gave. The only thing that's going to change is if I give you a problem about, I don't know, inventory, you're going to have stuff about inventory. If I'm going to give you a problem about purchasing, you're going to have stuff about purchasing in there. Questions on the open-ended portion? All right. Well, I know it was not the class that anyone signed up for, but I appreciate you guys persevering through it and showing up for all these meetings. If you do have any questions or concerns prior to the exam, please feel free to email me. I will be putting in all of the Bitburner. I've got a bunch of Bitburner assignments people have sent me. I will put all those in. And the final database assignment, I will put that in over the weekend. So all the grades are in there. If you haven't done the Bitburner assignment, do what you can. I mean, if you don't get to 100 in every area, turn in what you got. I will give you some credit, probably fairly generously. So that's that. If you are getting nasty grams about filling out a course exit survey, please do so that you stop getting emails every couple days from the CIS department asking you to fill out the course exit survey. Right. He said to the silent room full of muted microphones, see you on Tuesday. If you have any questions, feel free to stick around. I'm going to stay online. As always, my cell number is on the syllabus, so give me a call if you have any problems.
Thank you.
Thanks.
Thank you very much.
Thank you.
Professor, I have a question after everybody leaves.
Sure.
Hey, Professor, you there? Can you hear me?
Yes.
I turned in that. I still have a 0 out of 25 for that coronavirus assignment, the one, and then I emailed you about it. It's fine if you didn't answer. I understand. You're probably getting hundreds of emails a day. Yeah,
James,
I just
right? James
Yeah.
and the coronavirus.
Oh yeah.
Okay. I will write this down so that I remember it, and I will check right after I get out of here. So
All right. Thank you.
Yep.
Thank you so much. All right. You have a wonderful day, Professor, and I'll talk to you.
All right. Good class.
Thank you.
Stop share. Chat. Yes. Okay. And run. Salt, you're okay?